Hey guys, these are the Academic Physics Unit 4, Section 3. So we're talking about energy, Part 1. So this is the first notes about energy. So what you should know is energy is all around you. That sounds very yoga-ish, feel the energy around you. You can hear it as sound or you can feel it as heat. I always have my heater on me right now, so I am enjoying the heat from my heater. Here are the main types of energy. So let me move my little picture. So you can see there's mechanical energy, which breaks up into potential and kinetic. There is sound or wave motion energy, chemical, electrical, light, heat, nuclear. And for today, we're mainly going to be talking about mechanical energy, potential, and kinetic. But basically, all of these, energy is the ability to do work, right? So sound is the ability to move air in a certain pattern that we hear as sound. Light is the ability to get a photon from one place to another, and all that. So, okay, all energy is measured in joules with a capital J. So mechanical energy, as you can see, breaks into two main types, potential and kinetic. So kinetic energy is the energy of movement. If you study kinesiology in college, you're going to be studying the movement of the body. And that kinetic energy is half times the mass, which is always in kilograms, don't forget that, times velocity squared. And velocity is meters per second. Potential energy for mechanical is the energy stored due to gravity. Now, there's other types of potential energy, like you might have the potential energy of a spring, which is going to be based on how much you stretch or compress it. There's going to be an adjusted formula for that. There's potential energy, there's other types of stored energy, like chemical energy is technically a type of potential energy, but this is just talking about mechanical. So what can lead to movement of things? And that's going to be gravity. So potential energy equals mass times gravity times height. So mass is still in kilograms. Gravity on Earth would be 9.8 meters per second squared. And height is going to be in meters. So how high off the surface of the Earth? There's something you need to know, which is called the conservation of energy. And you've probably heard in chemistry the conservation of mass, which is when mass can't be created or destroyed, right? Well, for the conservation of energy, it's just saying that energy can't be created or destroyed. It can be only transferred to another type of energy. So you might have some electrical energy that's converted into heat energy. What? Like my handy dandy heater, right? But what we're going to be talking about is potential energy converted into kinetic energy or vice versa. But here's some examples, like light energy is converted into chemical energy through photosynthesis. We've got electrical converted into thermal, chemical into mechanical, chemical into mechanical, so all sorts of things. All right, if you check out this picture, if you throw a basketball up in the air, you know that the most potential energy is going to be at the very top, because potential energy is how high something is off the ground. So when it reaches the top, that's the most potential energy. But you also know that it's moving the least. At the top is when the velocity is going to be 0 for that moment, which means at the bottom is going to when it's moving the fastest, whether it's up or down. We're talking absolute value here. So we have an equation, the conservation of energy. It first looks like this. You'll notice gravitational and kinetic energy is going to be equal to some constant. Now I'm going to get into what I mean by this by a constant. So if the work done on an object is a conservative force, and a conservative force is when the work done does not depend on the path taken, but just the initial and final positions. Like if I take this calculator and I lift it this way, this way, this way, this way, the work done is only from here to here. It doesn't matter what path I take. If this happens, then the energy is conserved in a potential and kinetic forms, as in potential plus kinetic is always equal to potential plus kinetic. Now, this potential energy might go up, in which case kinetic energy goes down, but overall it's going to be equal to the same amount, which you saw in your roller coaster lab when you did your graphs. They all ended up being about the same height. So we have this a problem. If the original height of a rock is 3 meters, calculate the rock speed when it has fallen to 1 meter above the ground. And before we had those kinematic equations, remember we had to take gravity and that was your acceleration. You figure out which of the 5 equations it is by what's missing. So this one makes it a little easier. Here's my picture here that I just kind of stole from Google, so please excuse. And in this, we're going to figure out what our initial and our final spots are. So on the top is initially when he was holding the rock 3 meters above the ground, and then final is right here when it's 1 meter above the ground. This is not to scale unless this man is a giant. All right, so initial mechanical energy is equal to final mechanical energy. Initially, the potential plus kinetic initial equals potential final and kinetic final. So here is our potential energy initial. So it's always mass times gravity times height. Initially, it was at 3 meters in height, plus your kinetic energy. How much was it moving at the beginning? Well, when you're holding a rock still, it's not moving, so it's 0. And that's going to be equal to your final positions. So equals your final potential energy. So mass times gravity times height, mass times gravity times height. Our height is now 1 meter, plus our final kinetic energy, which is half mass times velocity squared. And if you look at this, there's some things we can get rid of. Plus 0 does nothing for you, so get rid of it. You can always get rid of a plus 0 in your equation to simplify. Now, when we look at all of these things, you notice they all have mass. So guess what? Bye. They all cancel. And now let's just simplify. So this is 29.4 equals 9.8 from 9.8 times 1 plus 1 half or half v squared. We're going to subtract 9.8 from both sides. 19.6 equals half of v squared. Divide both sides by 0.5. And 39.2 equals v squared. And to get rid of that square root, and velocity final is going to be 6.26 meters per second, but I'm saying negative because it is in the down direction. All right, have fun with energy, and I'll see you in the next set of notes.